tests.
Thank you. Hello from my side. Today I'm talking about discriminating intermediate AMD from normal aging changes using multiple visual function tests, and I'll present to you what we learned from the MACUSTAR study so far. So the MACUSTAR study is a multi-center European observational study with two study arms, one cross-sectional and one longitudinal, and I'd like to present to you data from the cross-sectional part here. So each person enrolled into the MACUSTAR study undergoes a battery of visual function assessments, including 4 chart-based tests, namely BCVA, low luminance visual acuity, Morpheus acuity test, the Pelly-Robson contrast sensitivity, a standardized reading speed test, and from microperimetry we take the mesopic and scotopic pattern standard deviation, as well as the rod intercept time from dark adaptation. And to compare the different discriminatory ability of all these tests, we used the complete case data from this cross-sectional part, leaving 122 intermediate AMD patients and 42 control patients or controls in the analysis that completed all of the above exams. And we previously published data on the discriminatory power of single visual function tests here. And to assess the discriminatory ability, we used the receiver operating characteristics and the corresponding area under the curve. And if the curve is in the upper left corner, it means perfect separability, and if it's on the diagonal, it means that it's not better by chance. And on this data set, so on the complete case data set, the ability is between 1.6 and 0.74. So the ability of single visual function metrics to discriminate is fair at best. And we were asked the questions, can the discriminatory power be improved if we combine multiple visual function tests, and can we reduce the number of assessments from 8 to maybe less in other settings, because 8 might be too much for a clinical trial setting. And to do this, or to combine tests, we used logistic regression models with all 8 visual function assessments, and we can see that we can improve the discriminatory power to 0.83, so we have a good separability. But if we now want to reduce the number of tests, we tried out all possible combinations in this cohort, and the ones that also showed an association with the outcome here, that were the Pelly-Robson contrast sensitivity, the rod intercept time from dark adaptation, and the scotopic pattern standard deviation from microperimetry. So if we reduce the model to only this, we still have a good AUC of 0.85, so good separability here. We could now say that we found the best combination ever to discriminate the no AMD from the intermediate AMD, but of course we did a complete case cohort analysis here, which might not reflect all the hurdles that we have in clinical trial settings, especially as the scotopic microperimetry and the dark adaptation require dark adaptation. We have more missing data in these cases, so most of the reduction of the original sample size comes from these trials. And the information that a patient cannot perform the test might be meaningful in these scenarios as well. And we might also ask ourselves, well, is it really worth the improvement? So if we only use the Pelly-Robson contrast sensitivity, it has a separability or AUC of 0.74, which might not seem so small, but we must remember, of course, that the AUC only ranges from 0.5 to 1, so this improvement might seem small, but is quite good, actually. So to conclude here, we can say, well, we can improve the discriminatory power when we combine multiple visual function metrics here. And here we found that the Pelly-Robson contrast sensitivity, the rod intercept time, and the scotopic pattern standard deviation had a similar performance as combining all the 8 visual function metrics that we used in the MACUSTAR study. But the order was really tight, so if we, for example, would use the MAT instead of the scotopic PSD, it doesn't, so it has a similar discriminatory power here. And we must conclude that even with a combination of multiple visual function assessment, it does not perfectly reflect the structural disease stage classification when we look at imaging data to classify intermediate AMD from no AMD patients. Thank you.
Thank you very much. Certainly, we still have a lot to learn about functional aspects of intermediate AMD. Can you tell us how do you see these results being applied in future? Are you going to just use those three or include the rest? And in what setting are we applying these findings?
So we still have the study ongoing in the longitudinal part, and we keep going with most of the tests for the extension. And of course, we also include the QCSF now in the extension study, which combines some of those metrics already.
Okay, thank you. I'd like to invite Marco Battista to talk to us about intraretinal fluid in intermediate age-related macular degeneration.